Beam element, beam theory. Element of plate and shield, theory of plate and shield. Solid element, behavior of solids, theory of elasticity. And there's a fourth behavior of structural mechanics. What is the fourth behavior of structural mechanics? They are the thin-walled beams. What is a thin-walled beam? There is a specific theory for that, right? Vlasov theory, for example, right? A Russian scientist who developed this here. A thin wall beam. It's a profile. I am going to draw a thin wall beam here. Look. It's a profile that has a length much larger than its width and its height. But we already studied this in the beam. Yes. We even made an example. That example of the software where we took a beam undergoing bending, but the width and height are much greater than the thickness, which is this part here. But why are we talking about this now if we already studied this in class? It's because a thin wall beam has a very interesting feature. Vital. When you study bending of a thin-walled beam, it's the same theory that applies for a beam with a solid section. The bending theory of this type of beam and that type of beam is the same. The value of the calculated nominal stress is the same. But when you take a thin wall beam, it has an interesting feature. Look, I'm going to take a thin wall beam here, and I will submit to torsion. When the beam has a thin wall, I will apply a force here and a force here to generate a torsion. When I do this on a thin wall beam, right, I do this here. I'm going to show you from the side, see what happens. A thin-walled beam under torsion has a fundamental characteristic. It has an axial displacement that is non-uniform along the contour of the section. It experiences the phenomenon we call warping, which you normally don't study in basic strength of materials. When someone studies torsion in material strength, they always study a very particular case, which is the torsion of a tube, right? The thing is, tubes have this unique feature. Everything circular has a unique characteristic. It does not warp. Every time you twist a tube, a closed circular tube, it just shears one section in relation to the other. It doesn't have the characteristic of warping, unlike what happens when you take a beam. That is very subtle.